So in this example, we are going to check uh, what is the stress in this body. Yeah, we will go for the normal stress in a y direction, and also we are going to check the von Mises stress and what is the displacement in this body. Yeah, the condition for the displacement is that it can't be exit more than 1 millimeter. Yeah, so if it is under 1 millimeter, the application will be acceptable, and this is the real based example which I have designed in my last job. uh, it was for the jigs and fixture. It was some kind of let's say some kind of a holder. Yeah, and here is the now the assembly is coming up on this hole. Yeah, and on the top they are putting some kind of the workpiece. Yeah, and up from up they're going to clamp it. Yeah, so it will be the some kind of static condition here. Yeah, so it's really important to analyze that what will be the deformation after such loading condition. Yeah, so loading condition for this is that I'm going to apply here 500 kilogram force. Yeah, in a y direction, vertically downward, and here will be the fixed constraint. So let me go to the application and go to the simulate. Yeah, the first I will apply the displacement here. It will be the fix. Yeah, in this surface and this one. Yeah, and I will keep this rotation at the moment as a free. Yeah, and the translation I will give as a fixed, as you can see here. Yeah, and just very simple, click OK. Go to the refine model and go to the surface region. After surface region, go to the reference and define the sketch. Yeah, sketch, and this one I will apply here. So this is that area where the load will act. It will be 40, and here it will be 80 millimeter. Yeah, click OK and control and select this surface. Click OK. Okay. Sorry for that. Okay, now I'm going to apply the load. Here, go to the force. Yeah, select the surface, this one, and vertically downward. I'm going for the kilogram force. Yeah, I can see here, it's here. Okay, and that one will be, here is that coordinate system, so it's something like y. Okay, so minus 500. Yeah, let's go to preview to just check and click OK. Okay, so here we go. Go to the refine model again and go for the control. Element size I'm going to give it 2 millimeter, and it will be component here. Okay, so everything is okay. I don't have assembly here, so I don't need to care about the bounded interface or any contact thing. So it's just for the review geometry when you are working with assembly mode. Yeah, it's helping you that where you are getting the interface or which kind of part has to be bounded and so on. We will talk definitely in upcoming videos, but so far uh, we don't need these kind of things at the moment. So we are just going to simply go to the home tab. We'll go for the analyze and study. Go to the new static, and I will give here bracket, let's say, and it's a single pass additive. It's real quick, so I will give us this one and click OK. yes, and let's wait for it. So we got the result. Let's check it. Okay, so first we are going to check about stress, and it will be one mice stress in megapascal. So click on megapascal. Display location is okay. Deformed, yeah, overly deformed. Scaling, I will go for the 5%, and continuous tone. Yeah, animate I don't need right now, so just go and click OK to show. Yeah. So we got something like this, yeah. So it's something like 146 maximum megapascal what we are getting. Yeah, let's open the model max. So it's somewhere here around. Where is the fixed constraint? Yeah, and minimum, it's here. Yeah, nearby the load. Okay, clear all text. Okay, and let's go for right now. We'll go to edit again and go to the displacement. Yeah, I will give component as a magnitude. I want in all direction. So just click OK and show. Okay. Ooh, so I'm getting approximately like 1 millimeter. Yeah. So the condition was that not supposed to be more than 1 millimeter. So it's quite okay for me at this point of moment. That's a really acceptable criteria here right now. Yeah. Go for trace again and select this time y direction. It's in kilopascal. Okay, I can change it to megapascal. Okay, and so okay, so in a normal direction I'm getting the 46 megapascal in a y direction. Yeah, so it's quite okay, I think, definitely. And if you would like to check the factor of safety, it will be something like around 2. Yeah, so we can go for stress. One mice stress, it's 146, and the material which I have assigned has approximately, I don't know, I'm not sure about it right now. It's like 300 or 400 megapascal. I'm not sure about it, but you can check basically by divided by the material yield strength. Yeah, so that's how you can do it a real simulation. And this was the one of the project of mine, what I would like to share here, that how I did my simulation. And that's all so far. Yeah, and if you want to go for measure here, you can get all the measurement. Yeah, so this is the what load is acting on this particular body with this loading condition. Yeah, so probably that's it for today's video, but I would like to show you something more as well. If you go to the edit, go to the display, go to the display option, and here you can go and animate as well. Even see that how your system is behaving with some certain loads. Yeah, so this is a unique way to work with Creo Simulate. Will give you more beneficial to just a quick check. Yeah, there are a lot of more options. Even you can go for the graph even. Yeah, and I will apply right now the displacement here in millimeter. Yeah, I will define, yeah, that where I would like to have it. Let's say where I have applied the stress. Yeah, just click OK, toggle, click OK, and here you can see. Yeah, so this is the like possible how you can even you can graph even if you would like to have it. Yeah, there are more possibilities how would you like to have it. So everything is possible in a Creo Simulate. So thank you guys for watching this video. That's it for today. See you in next.